For this linear transformation involving the transformation of R3 to R3, because we have here three components and we have 1, 2, 3 components here as well, we need to find the inverse of this linear transformation. The inverse here will use the following steps. We start with the standard matrix of our linear transformation, and since it is an R3 to R3, we expect that our matrix is a 3 by 3 matrix here. After that, we're going to show, or we're going to find out if the inverse of the given standard matrix or identified standard matrix is present. If it is, then we can say that T is invertible. But if it's not, then we can automatically say that our linear transformation doesn't have any inverse. Once we could express the inverse of our standard matrix, we're going to multiply it with a certain vector containing these components to finally find our inverse of the linear transformation of T. So let's start here with the standard matrix of this linear transformation using these entries here. Of course, the coefficients of x sub 1 will be on the first column, x sub 2 second column, x sub 3 third column. So for the first entry, that's x sub 1 plus x sub 2. So that's 1, 1, then 0 here. Our next entry is x sub 2 plus x sub 3. We don't have x sub 1, x sub 2, x sub 3. And finally, we have x sub 3 plus x sub 1. So you could always start here. It's commutative. X sub 3, x sub 1, and we don't have here x sub 2. This is the standard matrix. And from this, we are going to determine if it's invertible. In short, we're going to solve for the inverse of this. The inverse for a 3 by 3 matrix will not be using the theorem involving determinant, because that's more specifically on for a 2 by 2 matrix. Here, we're going to use this concept. The augmented matrix involving our standard matrix A and the inverse in R3. Okay? We're going to come up with the augmented matrix of the two and then apply necessary row operations so that this will be in the form of I here, meaning this will be an inverse, or I mean identity in 3 by 3 matrix. And what happens to this after applying the same row operations will become your inverse of A. So let's do that for this specific given here. So we'll have our A 1, 1, 0, 0, 1, 1, 1, 0, 1 to be paired with our 1, 0, 0, 0, 1, 0, 0, 0, 1, the identity matrix for a 3 by 3 matrix. So let's make this identity in identity form. So this is already 0 here, so we don't need that. What we need to do is to make this 0 by multiplying negative 1 to row 1 plus row 2 for a new row 2. There is still 1, 1, 0. There is still 1, 0, 0. For a second row, negative 1. This is row 3, by the way. We are not manipulating row 2, so it's still like this. Now on row 3, we have negative 1 times 1 is negative 1 plus 0, 1, 0. Negative 1 times 1 is negative 1 plus 0, negative 1. Negative 1 times 0, it's still 0, so there is still 1 here. Applying the same on the second, negative 1 times 1 is negative 1 plus 0, negative 1. Negative 1 times 0, so that's 0, 0 here. There is still 1 here. Okay, next is to make this a leading 1. That's already a leading 1, so let's make this 0 here. Let's manipulate this later as we move backwards. Simply add row 2 and row 3 for a new row 3. So we do not touch the first row. We are also not touching second row, but we are going to add second and third row to get the new third row. 0 plus 0, 0. 1 plus negative 1, 0. 1 plus 1, 2. Here you have 0 plus negative 1, negative 1. 1 plus 0, 1. 0 plus 1, 1 here as well. Then to make this leading 1, you're going to come up with 1/2 of row 3. Okay. So 1/2 of row 3, this is equal, by the way, equal. So 1/2, 1, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, that's 1. This would be negative 1/2 That's 1. That's 1 half rather. That's 1 half here as well. Next, let's make this 0 working backwards. Multiplying negative 1 to row 3 plus row 2 for a new row 2. Okay? So the third row will be unchanged. Negative 1 half, 1 half. The first row is also unchanged. The second row will be changed like this. Negative 1 times this plus that, still 0. Negative 1 times 0 plus 1, that's still 1. Negative 1 times 1, negative 1 plus 1, 0. Negative 1 times 1 half is positive 1 half plus 0, positive 1 half. Negative 1 times positive 1 half is negative 1 half plus 1. So you have positive 1 half, right? Then let's erase this. Sorry. Okay. Next, negative 1 times 1 half is negative 1 half plus 0, negative 1 half. Finally, let's make this 0 by multiplying negative 1 to row 2 plus row 1 for a new row 1. That's 1. Okay? Third row is just the same. Negative 1 half, 1 half, 1 half. Second row is also just the same. Positive 1 half, positive 1 half, negative 1 half. But the first row will still be 1. Negative 1 times 1 plus 1, 0. Negative 0, so 0, 0 as well. Okay, here, negative 1 times 1 half is negative 1 half plus 1, positive 1 half. Negative 1 times 1 half is negative 1 half plus 0, negative 1 half. And negative 1 times negative 1 half is positive 1 half plus 0, so positive 1 half. This now reach our identity in 3 by 3 matrix, and this would be our inverse of A. Okay, so that would be our inverse of A. Let me rewrite here the inverse of A. So 1 half, negative 1 half, and then 1 half. Let's make this better. Then you have positive, positive, negative. Positive 1 half, positive 1 half, negative 1 half. And negative, positive, positive. Negative 1 half, positive 1 half, positive 1 half. This is again the inverse of our standard matrix of A, but we are not yet done. Since we were able to identify the inverse here, automatically we can also say that our T is also invertible, and that is the goal here. So let's try to continue. We multiply this by a certain vector V with just the components x sub 1, x sub 2, and x sub 3. So the entire inverse, 1 half, negative 1 half, positive 1 half, positive 1 half, positive 1 half, negative 1 half, negative 1 half, positive 1 half, positive 1 half, to be multiplied with x sub 1, x sub 2, and x sub 3. Okay? So the result will be here. You will have 1 half of x sub 1 minus 1 half of x sub 2 plus 1 half of x sub 3. It's just one entry, okay? Because this is a 3 by 3 matrix to be multiplied by 3 by 1. Our result is also 3 by 1. So this is just one entry. You will have only one column. Next, positive 1 half of x sub 1 plus 1 half of x sub 2 minus 1 half of x sub 3. And you have negative 1 half of x sub 1 plus 1 half of x sub 2 plus 1 half of x sub 3. This would be the components of your, I don't know if the spaces are enough. Let's make this here. Okay. So the inverse of your linear transformation described by x sub 1, x sub 2, and x sub 3 vector is equal to the first entry, 1 half x sub 1 minus 1 half x sub 2 plus 1 half x sub 3. Then 1 half x sub 1 plus 1 half x sub 2 minus 1 half x sub 3. And then negative 1 half x sub 1 plus 1 half x sub 2 plus 1 half x sub 3. Okay? Or you could always factor out x 1 half rather. So we'll have here 1 half of this form, x sub 1 minus x sub 2 plus x sub 3. Okay? Then you have 1 half x sub 1 plus x sub 2 minus x sub 3. Then 1 half, you will have here, 1 half minus x sub 1 plus x sub 2 plus x sub 3. Okay, or let's have this final form. We have x sub 1 minus x sub 2 plus x sub 3 all over 2. Then x sub 1 plus x sub 2 minus x sub 3 all over 2. And you have negative x sub 1 plus x sub 2 plus x sub 3 all over 2 as well. This is the inverse of the linear transformation of t described by this linear transformation. Of course, again, this will be the entire process here. Thank you very much for watching.